Moving on to meaning of behaviors. So one of the things we all know is the understanding and the science on brain and behaviors is so fast evolving. We know more and more and more of how this is. So obviously, I have the advantage of having picked up on the information and the knowledge in the last 5 years. And in order to understand, and this is one of the conversations we have all the time, is in order to understand abnormal, one must understand normal. What are the normative parameters of any given thing? I'll give you an example. If someone comes to me, you came to me and I gave you an MMSC and you scored 24, God forbid, your medical records will thereafter be riddled with a dementia. But we do not have any normal data. We haven't gone out there and said, let's bring 500 normal people between the ages of 50 and 55, 55 and 60, 60 and 65, and give them MMSE to see what is the standardized curve. Because I can tell you, if anybody's going to examine me 20 years from now, I have a hard time remembering words and names. So if you gave me on an MMSE those words that start with F, I will not be able to do it. I cannot do it today, I cannot do it then. So we don't have normatives, and that's very, very integral to understanding what we do. So basically, the next little bit we're going to talk about the normal part of brain and behavior. And then we'll go to abnormal, because unless you understand normal, it is difficult to comprehend abnormal. Here is an approach that I have simplified as much as I can, and certainly using terminology that is reasonably self-explanatory. Our bodies are, you can break it down into 3 big systems. You have body circuits. We all know our bodies carry information to the brain. And then you have brain circuits. And brain circuits are the ones which assimilate all the information from the body to make sense of it. And then after the brain circuits have put all of that information through processing and assimilation, it leads to formation of brain functions, which then allow you and I to function, quote unquote, normal. And what are the brain functions? Basically, these are 4 big areas. The first big area is the higher cortical intellectual functions. This is your cognitive testing functions. So when you do MMSCs and MOCAs, this is what you are evaluating, higher cortical intellectual functions. Then, of course, the second most important function our brain does is thinking functions. We're all human beings, and our biggest peril is we think too much. And then the third important function are the emotional functions, because when we think, obviously it leads to emotions being generated. So if I'm thinking about something that somebody did something to me, my emotions are going to be, I get cross, I get upset. If I'm thinking nice things, I feel warm in my emotions. And then once the emotional functions have been generated, then that energy from the emotional functions or emotions is then fueled into social behaviors. So these are the broad 4 areas of brain function. And we're starting to now talk about, to begin with, higher cortical intellectual functions. We're going to try to understand those. And We talked about the brain circuits. So the brain circuit that subserves higher cortical intellectual function are the information processing circuits. So the brain, as you know, is one of the most complex parts of our body. And it is riddled with, I think, gazillions of neurons, nerve cells, which form such integral circuits that, as I understand, even the biggest, most complex, comprehensive supercomputer does not have the complexity of what the brain does. It's amazing. And the more you delve into it, the less you understand why it happens. There is information processing cascade. There are information processing theories. And neuropsychologists, we recently have a neuropsychologist, Dr. Sue. She spent 8 years looking at these information processing circuits and information processing cascades. And that is why they do neuropsychological testing. So this is what it is. So the thing I want to point out to you is the different kinds of memories. But the important thing is the working memories, which are the short-term memories, are the ones which give rise to long-term memories. And it's only after the memories are formed does all that information get put into a part of the brain that's called the association cortex. You know, we keep talking about the frontal lobes and stuff, and why frontal lobes are so important, because only parts of the frontal lobes are a part of that associational cortex. Anything happens there, you really have no idea what's happening. And it's the second last pit stop, associational cortex. And that is the single most important part of the brain where all the information goes in. And once it goes into it, then the next step is formation of higher cortical intellectual function. So what are these higher cortical intellectual functions? And you guys are very familiar with that terminology. Executive functions, visuospatial, memory, short-term and long-term, language functions, praxis, gnosis, which is, praxis is motor, doing things. Gnosis is recognition, auditory, visual, all kinds of recognition, and then insight and judgment. So when you do all your testing, when you go back to pieces, when you do the intellectual function, when you do these tests, the reason why we do MMSE and MOCA is because we're trying to do is evaluate different aspects of higher cortical intellectual functions. What MMSE does not do for you, MOCA does for you. And MOCA does it in the form of executive functions, which MMSE does not. It doesn't address it. So you can have someone with a great MMSE score, yet have executive dysfunction and severe neurocognitive disorder. Other terminology for that are the frontal lobe dementias. Those are the banes of our existence. The number of conversations we have about is this person, does they know what they're doing? Because they're so well preserved. They talk to you like I'm talking to you, but really it's a challenge. So it's this higher cortical intellectual functions which you are. And the other important thing is this is the first layer of brain function. This has to be intact for all the other brain functions to even begin to work. So this is the first layer, the first base. It's almost like the foundation of everything we do, is you have to have preserved information processing circuits. Only then can you have formation of higher cortical functions. And if higher cortical functions are not preserved, then all the other brain functions we've talked about will be impaired. So that's the key thing you must remember. Now we go on to the next part of the brain function, which is the thinking function. Going back to the other component, which is which brain circuits in the brain subserve thinking functions. And we have one of the most complex motivational circuits in our brain. Motivational circuits are the ones which are important for the higher cortical intellectual functions, which take information from internal and external environment of the body, and it leads to generation of thoughts. And I'm going to give you some examples of this a bit later as how this functions and for you guys to understand. But again, the key is you have to have preserved higher cortical functions for it to assimilate ongoing information, for you to have any thoughts of substance and meaning. So the next layer after the higher cortical intellectual functions is the layer of thinking functions, which is the motivational circuit. So you've got the information processing circuits, then you've got the motivational circuits. The third important function is the emotional function. And again, as we talked about it, the higher cortical intellectual functions have to be preserved. The motivational circuits have to be preserved. So thinking has to be preserved for you to then put that information into that associational cortex. It goes back into that black box where it leads to generation of emotions. And the generation and regulation of emotions are again controlled by very, very complex emotional regulatory circuits. So there are parts in the brain which actually regulate generation and regulation of any emotion that is formed. And the preservation of these circuits is integral for that. So this is the third layer in the brain function. The information processing circuits, the motivational circuits, and now on top of it, the emotional regulatory circuits. Once you've got your higher cortical functions, your thoughts, and your emotions all preserved, then all of that information again goes back into the associational cortex. And when it does, it leads to generation of social behavior. I refer to it as social adaptation and learning. It's a phenomenon we do every day. Social learning, social adaptation. But these are all parts of social behaviors. And these social behaviors are controlled and regulated by self-monitoring and regulatory circuits. And one of the things you often find, we talk about in our individuals with persons with dementia, they've lost their ability to be self-aware of what they're doing. They've lost their ability to monitor what they're doing. They've lost their ability to track what they're doing, and therefore lost their ability to regulate what they are doing. Because social behaviors are the highest version of human expression. And that is what gives us dignity, poise, and everything else, is we continuously regulate ourselves in a way that is appropriate. And so those are controlled and regulated by self-monitoring and regulatory circuits. And again, these circuits are all over the brain and they're all intertwined. But again, the important thing is you have now layers. It's like foundation, the base, higher cortical, followed by thinking, followed by emotion, followed by behaviors. And this is where the beginnings of CBT came in as well, cognitive behavioral therapy. Thoughts, emotions, and behaviors. You take thoughts, which lead to generation of emotions. Emotions are the energy for behaviors. So how do you change behaviors? By changing thoughts. So the paradigm of CBT, so it all falls back to these common tenets of brain and behavior. In a pie chart, again, these are stacked on each other. I just didn't know how to do it. Information processing circuits are the key, followed by motivational circuits, followed by the emotional regulatory circuits, and then finally the self-regulatory or monitoring circuits. Let's overlap this again so that it represents each part to itself. So the information processing circuits are the ones responsible for higher cortical functions. Motivational circuits are responsible for thinking. Emotional regulatory circuits are responsible for generation and regulation of emotions. And self-regulatory circuits are responsible for modulating social behaviors. And so this is another way of coming back to where we started, which is the brain functions and the circuits which are in it.